5.1b, using trig fundamental identities again. All right, so hopefully we know what reciprocals are. All right, and so if I have like tangent on the bottom, that's really cotangent, right? And so forth and so on. So those are our reciprocals. Our quotient identities, sine, or tangent is sine over cosine. Cotangent is cosine over sine, right? Our Pythag identities, the only one that I need you to memorize is sine squared plus cosine squared is equal to 1. How do you get these other two? Divide by sine squared and divide by cosine squared. All right, that should give you those. All right, so we talked about our cofunction identities in 25 through 36. And then we talked about even and odds. Now, what's the trick about even and odds? We got a sign in it, what happens? The negative comes out. All right, so here we go. So this first one we have is sine theta over 1 plus cosine theta plus cosine theta over sine theta. And I'm asked to simplify this one. Well, how the heck do we add something? We need common denominators. So what's going to be my common denominator? Good. All right. So think about it, guys. If you have like 1/3 plus 1/5, what's the common denominator? 15. What'd you do to the denominators? You multiplied them. So if I have this, my common denominator would end up being sine theta times 1 plus cosine theta. All right. And so what does this left fraction need? What does that left fraction need to be multiplied by? Sine theta. All right. So I need to multiply sine theta times sine theta, which is sine squared theta. All right. And then plus cosine theta needs to be multiplied by 1 plus cosine theta. All right. So now I'm going to distribute. So when I distribute the top, I end up with sine squared still left up. And then cosine theta times, or plus, cosine squared theta. All right. And then leave the bottom kind of factored out. You'll see things happen a lot. All right. So don't distribute the bottom most of the time, unless it's a conjugate. Unless it's a conjugate, I would keep it in factored form. Now, do you notice anything? What? There's two squared thingies. So what's probably going to happen? I'm going to use some identity. Now this one's pretty nice. What do I know about the identity? Sine squared plus cosine squared is equal to 1. All right. So now up top, I end up having 1 plus cosine theta over sine theta times 1 plus cosine theta. Well, what happens now? 1 plus cosine thetas cancel, so that's really cool. What's left up top? A 1. So now I have a 1, and then I have sine theta on the bottom. Well, I need to go one more step. What is 1 over sine theta? Cosecant theta. All right. So we actually simplified this whole thing into cosecant theta. All right. We're going to rewrite 1 over 1 plus sine x so that it is not in fractional form. This is one of my most missed questions on the test. This one. All right, this kind of problem is one of my most missed questions on the test. And I told you before I'd be like, idea of what to do so it's not in fractional form. Good. We multiply by its conjugate. All right, just like we did those a plus bi things, it's the same kind of concept. So if I multiply by its conjugate, I can get something squared. So that's really cool. So what's my conjugate? 1 minus sine x over 1 minus sine x. All right. So when I do so, what's my numerator? 1 minus sine x over 1 minus sine squared x, or sine x squared. All right. Well, what is 1 minus sine x squared? I got the squared thingy going on. So what is 1 minus sine squared? Cosine x squared. All right. So now I end up having 1 minus sine x over cosine squared x. However, it's still a what? Still a fraction. So the way we need to do it is we need to distribute dividing. All right, I have a monomial on the bottom, and so I can distribute dividing. So now I have 1 over cosine squared. All right, so I have 1 over cosine squared, and then I have minus sine x over cosine squared. Well, what the heck is 1 over cosine squared? Secant squared. All right, so now we have secant squared over here. And then minus, I could call this sine x secant squared x. I could call it that. All right, because if you divide by cosine squared, it's really multiplying by secant squared. You following me? All right, but I want to show you another way to tampa. How many cosines do I have on the bottom here? I have 2 of them. And so if I work with that left or that right fraction, I would have like sine x over cosine x. And then I'd still have like 1 over cosine x because I have 2 cosines on the bottom. You following me? And so if I were to rewrite this in a different way, well, what's sine x over cosine x? Tangent. All right, and so I'd have a tangent x times secant x. All right, and then I still have secant squared x. That one has to be that. These two are the same thing. All right, these two are the same thing. Okay, and we're either one of them in fractional form. No, so if it's a free response, I can accept both of those answers. Are you following me? All right, but it may or may not be. All right, so we're going to use U substitution. I'm gonna say x is equal to 2 tangent theta, and I'm going to write square root 4 plus x squared in terms of theta. All right. So all I have to do is take what x is and substitute it in my equation. All right. So now I end up having what? Square root of 4 plus the quantity of 2 tangent theta quantity squared. All right. And then we just got to manipulate a little bit. 2 tangent theta quantity squared is actually what? 4 plus 2 squared is 4. Tangent squared is tangent squared. All right. What could you factor out of those 2 terms? A 4. So when we factor out a 4, I'm left with 4 times the quantity what? 1 plus tangent squared. All right. Well, you should notice something now. What is 1 plus tangent squared? Secant squared. So now I end up having square root of 4 secant squared. Now, are both of them perfect? Yes, they're both perfect. So what do we end up having? 2 secant theta. All right. Pretty good? All right, so now we're going to rewrite these logarithms into a single logarithm, and then we're going to simplify it. All right? These are flip claps for chapter 3, for chapter 5. Yeah, it's coming back. All right? So, in logarithms, I know, logs and trig mixed together. Ah, all right. Blasphemy. So, what does it mean to add? What does it mean to add log? Multiply. What does it mean to subtract logs? Divide. That's all we need to know, really. That's all we need to know. All right? So, if I have natural log of cosecant theta plus natural log of tangent theta, if I condense this, we have addition going on, so that means multiply. So now I have natural log of absolute value cosecant theta, then what? Times tangent theta. But it asked me to simplify the results, so what the heck is cosecant? 1 over sine. And what is tangent? Sine over cosine. So what happens? The sines cancel, and I'm left with 1 over cosine, which is what? Secant theta. So this is the same thing as natural log of secant theta. All right. There we go. That one's a llama. That one's a llama. That's an alpaca. That's an alpaca. That one's a llama. All right.